All right, friends, we're getting into the harder ones here. This is a proof involving congruent triangles and segment or angle bisectors. So now they're not going to start telling us what kind of congruence theorems we're going to use, which I think is great. You guys are going to have to figure it out. But they are going to start throwing some words at us in our givens, which I also think is great. We have to start picking that apart. Okay? So again, we're going to start in Notability and then move back to ALEKS. I want us to figure out what the plan is and then move over there. So let's see here. In this first bit, DC congruent to AC, go mark it. Those are equal. Okay, and probably before you get on to this one, because that seems intimidating, you could mark your vertical angles, because yes, those will definitely be part of this. Okay, now DA bisects EB. Okay, when we say DA bisects EB, DA bisects EB. Bisects, of course, means cuts in half. So one is cutting the other in half. This guy right here is the knife. And this is the segment being cut. All right? So pay attention to what's happening to what. So let's see, DA, shwing, just cut BE in half. And BE is now cut into two equal pieces, or EB. I keep saying it backwards because they wrote it not alphabetically in order. That's annoying. Okay? So you have to read it just as it said. DE, or DA, is bisecting EB. Right there. This makes this a segment bisector. It is bisecting a segment. Not all the time is bisect going to be bisecting a segment, okay? So let me write this out. Bisect could be could be cutting a segment, or an angle. Pay attention, okay? It could be an angle bisector, could be a segment bisector. You have to pay attention to what that thing is that it's cutting in half. And then you have to write it out appropriately, okay? So if it says something like, it could be something that looks like this. Could look like this, DA, BC, and it could say DA bisects angle, I didn't give myself much space there, bisects angle BAC, and then all of a sudden, these are the same. And now you have to write out a statement that says something like angle BAD is congruent to angle CAD. Okay? This is a very different scenario to what's happening up here. So watch out for what's happening with that bisect word, because it does things. Okay, so that was a little tangent there, but I want you to be watching for that. All right, so now let's look up here. Now that we've got this all drawn out, what kind of triangle congruence do we have going on up here? We have two sides and an angle. Side, angle, side. That is side, angle, side congruence. All right, well, let's head back over to ALEKS and write it in. So we're going to send those to proof. Oh, sorry, I put my keyboard away. Let me pull it back out. Side, angle, side congruence. All right, I'm going to put in my vertical angles because they're easy. Everybody likes those. BCA is congruent to angle ECD because of vertical angles. Did I pass it already? Nope, there we go. Validate. All right, now let's deal with those bisected ones. DA bisected EB. So that means now we've got BC, which is congruent to CE. And the reason is because of the definition of segment bisector. And now I have 3 congruent statements. 2 of them are segments, one's an angle. So now I can send a proof and do my side angle side. All right, I hope that made sense.